So we are still on the June 2025 past exam paper from Limpopo, grade 12 pure mathematics. So we were on question 6.1. So the question was saying calculate the derivative of f of x equals to 3x squared minus 2x from the first principles. Then 6.2, it was saying determine lim as h approaches 3, 2x squared minus 11x plus 5 plus 15, so plus 15 over 3 minus x. Then 6.22, it was saying g prime x if g of x equals to x to the power 4 minus 4 over x. Then 6.23, it was saying dy dx if y equals x plus 3 minus x. Then 6.24, dx 3 root x minus 4 over root x. Alright, then the last part was 6.3, that was saying determine the equation of the tangent to f of x equals to x squared minus 2x plus 3 at x equals to minus 2. So these were the questions from question 6, right? So let's start with 6.1, where we calculate the derivative of f of x equals to 3x squared minus 2x from the first principles of derivatives, right? So the first principle of derivative, what does it say? So the first principles of derivative, remember, this is where we said f prime x equals to the limit as h approaches 0, f of x plus h minus f of x over h. And remember, the question was 3x squared minus x, right? So now we want to evaluate f of x plus h. So our f of x plus h now is 3x plus h squared, because we are having this squared, right? Then minus 2x plus h minus 2x plus h minus for the x plus h is representing that. Then we say, so this is equal to, so first by expanding that bracket. So how do we expand that bracket? So we can now say 3, then we say x plus h, then plus h x plus h, like that. then we say minus, so we're also having another bracket, so let's expand this already. So 2 by x, that's 2x minus 2h, right? Then we come here, so we're saying 3, so this becomes x squared plus xh plus xh, because we're saying x times h, xh times h, so it's xh plus xh, then h times h, that's a squared minus 2x minus 2h, like that, right? Therefore this becomes now x squared plus 2xh plus a squared minus 2x minus 2h, like that. Alright, then we come to a point now where we want to put this back into the function, so we can now say that this implies 2. So we can say that this implies 2. We multiply the bracket, so we can say now f prime x equals to the limit as h approaches 0, then we expand the bracket, so we're going to get 3. So we're going to get 3x squared plus 6xh, because we're saying 3 times x squared, that's 3x squared, 3 times 2xh, that's 6xh, then 3 times h squared, so that's 3h squared, minus 2x minus 2h over h, like that. Alright, then from there, now we want to find f of x plus h minus f of x over h. Alright, so we are now saying f of x plus h minus f of x over h must give us, right, 6xh plus 3h squared minus 2h over h, like that. So we're saying over h. So if we divide, we can remain with 6x by this h, 6x, right? When we factorize this h, or when we divide this h by h, the whole function by h, so we're going to remain with 6x plus 3h minus 2, right? Then from then we evaluate, from there we can evaluate the limit. So let's go to the limit. So the limit, so find the limit as h approaches, find the limit as h approaches 0. So we're saying f prime x equals to the limit as h approaches 0, 6x plus 3h minus 2. So we're going to remain with, so when this becomes 0, so we're saying as h approaches 0, we're going to remain with f prime x equals to 6x minus 2. This will be our final solution when we want to find the limit as h approaches 0. We are going to have f prime x is 6x minus 2. So that was the first part of question 6. Then the second part of question 6 was saying determine the limit. So question 6.21, question 6.21 was saying determine the limit as h approaches 3. So it was saying determine the limit as h approaches, so determine the limit as h approaches, so we're saying the limit, determine the limit as h approaches 3, in this case approaches 3, where we are given 2x squared minus 11x plus 15 over 3 minus x. So what we can do first, let's factor out the numerator. So let's factor out the numerator. So the numerator we're having 2x squared minus 11x plus 15, right? So when we factor out, we are going to get 2x minus 5 and x minus 3, right? Then from there, let's rewrite the expression, right? So now let's rewrite the expression. So we can say 2x squared minus 11x plus 15 over 3 minus x equals to this one, where we say 2x minus 5, x minus 3 over minus x minus 3, like that. Then let's simplify the expression. So we want to simplify the expression for x equals to 3, right? We want to simplify the expression for x equals to 3. So now that means we can say 2x minus 5, x minus 3 over minus x, x minus 3, right, equals to minus 2x minus 5, like that, which is equals to minus 2x plus 5, right? Then let's evaluate the limit. Now let's evaluate the limit. So now we want to evaluate the limit. So the limit we are having minus 2x plus 5, right, equals to minus 2. And remember, we said as h approaches 3, so we're going to put 3 for x because our h is approaching 3, right, plus 5. So this one we are saying minus 2 times 3, that's minus 6, plus 5, we get minus 1. So this is the answer for the question where we wanted to evaluate the limit as x approaches 3 to x squared minus 11x plus 15 over 3 minus x. So that was the solution for that question. Then the next question, question 6.22, it is saying determine g prime x if, so this one is saying g prime x if g of x equals to x to the power 4 minus 4 over x, right? So we can rewrite this function. So we can say x to the power 4 minus 4x to the power minus 1, like that. Alright, so now we can now say d over dx, right, x to the power 4 minus d over dx 4x to the power negative 1, like that. Right, so now we can evaluate and we can now say, so this is 4 times x to the power 4 minus 1, right, minus, right, so we already have the minus sign, so I can now say minus 1 times 4x to the power minus 1, right? Therefore here we can say 4x to the power 3, because 4 minus 1, that's 3, so minus whatever that is in the bracket, so I'm saying minus 4x minus 2, like that, minus 4x minus 2. That means now we can say now this is equals to, so our minus and the minus gives us a plus, so we can say 4x to the power 3 plus 4x to the power negative 2, which is equals to, we can now say 4x to the power 3, right, plus 4 over x to the power 2. That will be the final solution for that expression where we are looking for g prime x if g of x equals to that. Alright, then let's determine dy dx in the next question. So we want to determine dy dx if y equals to x plus 3 minus x, right? So let's first start by expanding y, right? So expand y. So the question was saying find dy dx if y. So we want to first expand y. So we can say x plus 3 minus x. So when we expand, we take the first term in the bracket, right, and we multiply by the second bracket. Then we take the second term of the first bracket, we multiply by the second bracket, like that. So now x times 3 is 3x, x times minus x is minus x squared, right, plus 9 minus 3x, like that. So now this is y now. So now if we want to find dy dx, we can now say d over dx of 3x, right, minus d over dx, or we can say plus of minus x squared, right, plus d over dx of 9 plus d over dx of minus 3x, right, of minus 3x, like that. Then from there we can now differentiate. So this one gives us 3. We are supposed to get 3. When we differentiate this, we are supposed to get a 3. But let's consider minus x squared, 9, and minus 3x. So if we're having 3x and minus 3x, they give us 0. So we're going to remain with a dy over dx equals to minus x squared plus 9, right? So we're going to differentiate this. So if we are differentiating this one, we can now say 2 times minus x to the power 2 minus 1 plus this one, it gives us 0. So 2 times minus x, we get minus 2x. 2 minus 1, we get 1. So minus 2x to the power 1 is simply as minus 2x. So that was the answer to the question that we were given, where we were supposed to find dy dx if y equals to x plus 3 minus x. Right? Then still on question 6, we are going to 6.24. So 6.24 was given as dx, alright, 3 root x minus 4 over root x, like that. So let's rewrite the expression. So let's rewrite the expression. So we can say 3 root x minus 4 over root x equals to, so we can say 3 root x over root x minus 4 over root x, right, which is equals to 3 minus 4x to the power negative half, like that. Then from there, so we are having this expression now. So let's differentiate with respect to with respect to x. Alright, so that means we are saying d over dx of 3 plus d over dx of minus 4x to the power negative half, like that. Right, therefore we come to that part. Now we want to differentiate with respect to x, right? So when I'm differentiating with respect to x, this one becomes 0. So let's deal with this one. So if that one, if you say minus half, right, minus half times 4x to the power minus half minus 1, right, what are we going to get? So when you say minus half, we're going to get 2x, because 2 into 4 is 2, so we're going to get 2x to the power negative 3 over 2, right? Was minus half minus 1, we get negative 3 over 2, right? Then from there we can now say 2 over x to the power 3 over 2, which is equals to 2 over x root x, like that. That is also true. Alright, so this can be our solution. You can leave it there. Alright, so now let's go to 6.3. We are still on question 6. Alright, 6.3 being the last part of question 6. That's 6.3. So 6.3, the last part of question 6. Alright, so it is saying determine the equation. So it is saying determine the equation. Determine the equation of the tangent. Determine the equation of the tangent to f of x equals to x squared minus 2x plus 3 at x equals to negative 2. Right? So let's find the y coordinate. So let's find the y coordinate at x equals to 2, because our function, it can be written as y equals to x squared minus 2x plus 3, right? So that means when we want to find the y coordinate, we are saying y equals to, we evaluate the values of x by assuming x values, since x determines the value of y, right? So but we are given x equals to minus 2, right? So let's evaluate when x equals to minus 2. So we can say y equals to, so when x equals to minus 2, we are saying now minus 2 squared minus 2 plus 3. So we are going to get, this one is 4, right? We get 4, this one again 4 plus 3. So we are going to get 11, like that. So if we find the y coordinate, that means the point is minus 2 for x and 11 for y. That will be the point. So if we find the point now, we are going to find f prime x of f of x equals to, so of f of x equals to 2x minus 2, right? Of 2x minus 2. So why 2x minus 2? So we are differentiating this one. So when we differentiate that part, we can say 2 So dy dx gives us now 2 times x to the power 2 minus 1 minus 2. There we're going to get 1, right? So that means we're going to get 2x minus 2. And we want to find the derivative of that one, that we can write as maybe f prime prime x, right? So when you want to find f prime prime x, that means we want to differentiate this again. So what do we get? So we can now say that slope of x equals to minus 2. So we're saying f prime minus 2 equals to, right, we're having there, that's 2 minus 2, this one 2 minus 2, because x equals to minus 2, minus 2, which gives us now, this is minus 4 minus 2, which gives us minus 6. Then we use, so let's use the point slope. Let's use the point slope 2. Let's use the point slope 2 form a line, because the question wants an equation. So this is where we say now y minus y1 equals to m multiplying x minus x1, right? And we know that the gradient is negative 6, so m is 6, right? So what can we say? Minus 2 minus 11. So remember, we have another point that we said minus 2 minus 11. Alright, so we are saying y, what is y? So y is 11. We can use our y as 11. So if y is 11, so we are saying y minus y1 is the one that we are evaluating, is 11, equals to m, the gradient, which is minus 6, multiplying x minus x1 that we are evaluating is minus 2, right? Then that means on the next point we are going to say, on the next point we are going to say so we'll first by expanding that bracket. So we're saying y minus 11 equals to minus 6 x, that becomes x plus 2, like that. So we can say y minus 11 equals to minus 6 times x, it's minus 6x, minus 6 times plus 2 is minus 12, right? Then we are having y minus 11 equals to minus 6x plus 12. So we can collect the like terms, maybe we can say plus 6x equals to minus 12 plus 11, right? Therefore we can say y plus 6x equals to minus 12 plus 11, that's minus 1, right? And we can simplify it, y is equals to minus 6x minus 1, like that. That will be the equation that we were being asked from the question. So this brings us to the end of question 6. Right?